Hunter Tobin here, RealAgriculture.com. We're down at the Simcoe Research Station, joined by Jason DeVoe, OMAS spray guy, right?
That's me.
So, Jason, it's mid-May, and we've had a tough spring. It's late, and one of the things we want to talk about is spray and spray drift. As those seasons get shorter, I guess the potential of drift increases because farmers have got to get things done in a hurry. And we want to talk a little bit about best practices and how to make sure you manage drift, because you can manage about 90% of drift potential by doing it right.
Absolutely. So we want to figure out where are the red herrings and where are the changes you can make to your spray program to really get the job done. So what we're going to do here today is a real down and dirty demonstration of 3 things that you can do to help prevent drift. We don't want it. It's a waste of money. It's a lot of trouble. We're going to show airspeed, high and low air, and what that does to droplets. We're going to show boom height, high and low, and what that does to droplets. And then finally, we're going to show what happens when you change to a larger mean droplet size, why big droplets are better than small droplets for drift. What we're going to do is a real simple demonstration of which factors will affect drift and which ones don't affect drift quite so much. The first thing we're going to do is, using this backpack sprayer, we're going to hold our boom at about 50 centimeters off the ground with an 8003 flat fan at 50 psi, which I'm going to try to hold steady here. And we're looking at 5 downwind targets. We've got a fan off camera running at about 10 kilometers an hour. We're going to spray for 20 seconds and see how far the pesticide, the water, drifts. So the first one at 50 centimeters, and then afterwards we're going to do it at about 100 centimeters, and we're going to take those cards and put them up on a board and compare them. The second trial we're going to do, we're going to look at droplet size. The first time I'm going to run an 8003, which is about a medium droplet size, at an ideal 50 centimeters. Then I'm going to swap this out for an air induction nozzle that puts out the same rate but uses extremely coarse droplets, and we'll see how far that goes. The last trial we're going to do, we're going to look at wind speed. We've all been told don't spray during high winds. We're going to see what impact it really has. We've got a fan set up that's going to spray about 10 kilometer an hour wind on an 8003 flat fan, again a medium droplet, and then we're going to crank it up to about 15 kilometers an hour and see if that spray blows any further. A lot of growers and operators will tell you, no, I'd never spray in a high wind, but they don't remember that when they're driving into a headwind, you get apparent wind speed. That nozzle experiences the speed of the vehicle on top of the wind that's blowing back at them. So we've collected our water-sensitive paper, and we've put them on this board to see if there's anything to show. I'm joined by Tara Wiedemann, our summer research student, and we're going to show you whether or not we got some results. This is the point of release somewhere over here. There's the water-sensitive paper 1.5 meters away from the point of release, 3 meters, 4.5, 6, and 7.5. And as you can see, there's more spray on the water-sensitive paper close to the point of release, as you'd expect, and less as you go out. The first experiment we did was changing the height of the boom. The second one was droplet size, and the last one was wind speed. Let's look at the first one. So here we have 2 boom heights, 50 centimeters off the ground, which is about ideal, and not recommended 100 centimeters off the ground. And let's take a look. You can see that at 1.5 meters they were both flooded, as you'd expect. And as you get further and further out, there's a pretty obvious difference that the boom that's higher off the ground is going to leave more and more residue behind further and further out. We've got spray on the papers all the way to 7.5 meters with no problem at all, and obviously less when the boom was lower. So that gives us our first point: keep your boom down. The second experiment was a medium droplet size and an extra coarse from an air induction nozzle. In this case, you can see 50 centimeters off the ground, there's more spray for the smaller droplet, because smaller droplets will drift further, and less spray on the targets for the extra coarse. It tends to fall straight down. And as we get further and further away, it's a pretty obvious difference. More spray here for the medium, more spray, less, more, and less. So we know using larger droplets means it won't drift as far. It doesn't stop drift, but it does knock it back. Our last point was wind speed. Should we be spraying in high wind? 10 kilometers an hour, pretty reasonable. 15 kilometers an hour, not so reasonable. And you can see right from the get-go the big difference. Higher speed wind is pulling more spray with the wind. 15 kilometers an hour versus 10, again pretty obvious. And all the way down the board, you can see that faster wind means more drift. So while we shouldn't spray when it's zero wind, and we shouldn't spray when it's gusty, we most certainly shouldn't spray when the wind is really high.
So although there doesn't seem to be a lot of apparent difference between 20 feet and 25 feet, the paper only absorbs droplets that are 50 microns or higher, so there are more droplets on these papers than there appears to be. And in addition to that, the concentration of the particles, of the droplets on these papers is also a lot more potent as it is at 5 feet, because as the droplet travels to this farther distance, it becomes more concentrated.
That's right, it's begun to evaporate. So the drops here, while potent, probably aren't as potent as the ones you see on the far side. So this season, when you're out and your spray window is pretty short and you're wondering whether you should spray or not, make sure you get the most bang for your buck that you can. It's a lot of time and money you're spending out there. Make every droplet count. Drop your boom as low as you're able. Go to a larger droplet size, and if it's really blowing, there's no point to spraying. You're just going to cause drift and your coverage is going to suffer. And remember, the nozzle will experience apparent wind speed. That means if you're driving into a wind, you have to add the wind to your travel speed. 15 kilometers an hour, you may be thinking, I'd never spray in wind that high, but I'll bet you'd drive 10 kilometers an hour into a 5-kilometer wind.